This is section 10.2, part A, arithmetic sequences and series. A sequence in which the difference between successive terms is constant is called an arithmetic sequence. The constant is referred to as the common difference, which we will denote with the letter D. To find the common difference of an arithmetic sequence, subtract any term from its succeeding term. To find the next term in the sequence, you would add the common difference to the given term. So we need to, on this example, determine the common difference and find the next four terms in the arithmetic sequence. So we're seeing what do we have to do to get from 17 to 12. So if we do 12 minus 17, we're going to get negative 5. Or if we would have done 7 minus 12, we still get negative 5. Since these values are the same, that means our common difference is a negative 5. So that means we have to add negative 5 each time to get to the next term. And now we need to find the next four terms. So if we have 7 plus a negative 5, that's going to give us 2. 2 plus negative 5 gives us a negative 3. 3 plus negative 5 gives us a negative 8. And negative 8 plus negative 5 gives us a negative 13 as the next four terms in our arithmetic sequence. Now, if we want to find the nth term of an arithmetic sequence, we can do this by writing a recursive formula, and a recursive formula would be a sub n is equal to a sub n minus 1, which means we take our previous value and we add our D value, or our common difference. If we want to write an explicit formula, so we don't have to know what the previous term is, to do that we would say a sub n is equal to a sub 1, so the first term in our series, plus n minus 1 times D, or the common difference. So we need to find both an explicit formula and a recursive formula for the nth term of an arithmetic sequence of 12, 21, and 30. So if we do 21 minus 12, we're going to get 9. And if we do 30 minus 21, we get 9. So we do know that our common difference will be 9. To write the recursive formula, you are just going to say that we're going to take a sub n is equal to our previous term, so a sub n minus 1, plus our common difference, which in this case would be D. We do need to say, if you're writing a recursive formula, we also need to tell them what the first term was so they can write the recursive, find the next term in the series. And this would be our first term, our a sub 1 is equal to 12. To write our explicit formula, we're going to do a sub n is equal to our a sub 1. Our first term in our sequence is 12, so our a sub 1 is 12. Plus n minus 1 times our difference, and our difference is 9. Now we can take that 9 and we can distribute it to the n and the negative 1. So this will be a sub n is equal to 12 plus 9 times n is 9n. 9 times negative 1 is negative 1. And if we combine like terms, we're going to get 11 plus 9n as our explicit formula for this sequence. We need to find the 68th term of the arithmetic sequence. So to do this, we're not going to want to write a recursive because we'd have to find the 4th, 5th, 6th, all the way up to the 68th. So we are going to want to write an explicit formula. Remember, to write that explicit formula, we're going to do a sub 1 plus n minus 1 times the common difference. So we know the first term in our sequence is 25. Now we need to find the common difference. So if we do 17 minus 25, we're going to get negative 8, and 9 minus 17 gives us negative 8. Our common difference is negative 8. So we can take that negative 8 and we're going to distribute it to both parts. So negative 8 times n gives us negative 8n. Negative 8 times negative 1 gives us a positive 8. And if we combine like terms, 25 plus 8 is going to give us 33 minus 8n as our explicit formula. Now with that explicit formula, we want to find the 68th term. So we're going to do 33 minus 8 times 68, because we're finding our n value in this case is 68. And it's going to tell us the 68th term in this sequence should be negative 511. We're going to do the same thing on the next one. So they already tell us that the first term is, we need to find the first term if I know the 25th term is 139 and we know the difference. So we're still going to start with the same formula. And we're going to plug in the information we know. So we know that our a sub n is 139. I don't know my a sub 1. We do know that it is the 25th term. And we know that our common difference is 3/4. So if I do 24 times 3/4, 24 divided by 4 gives us 6. 6 times 3 gives us 18. I'm going to take that 18 and I would take it to the other side. So I would subtract 18 from both sides. And we would get 121 as our first term. If two non-consecutive terms of an arithmetic sequence are known, the terms between them can be calculated. These terms are called the arithmetic means. So we're going to write an arithmetic sequence that has 4 arithmetic means between 4.3 and 12.8. So that means I have 4.3, I have 4 blanks, I don't know what they are, and then I have 12.8. So we do know that our first term is 4.3, and because there's 4 blanks, we know our 6th term is 12.8. Now we're still going to start with that explicit formula. So we have a sub 1 plus n minus 1 times the common difference. Our a sub n would be that 12.8. Our a sub 1 we know is 4.3. Our n value is which term it is, and that one is the 6th term. So this is going to give us 12.8 is equal to 4.3 plus 6 minus 1 gives us 5d. If we take that 4.3 to the other side, to do that we're just going to subtract it. This is going to leave us with 8.5 is equal to 5d. If we divide both sides by the 5, we're going to see that our common difference would equal 1.7. So that means we would need to add 1.7 each time. So if I was at 4.3, to get to the next term, I'm going to add 1.7, and that's going to give us to 6. If I add another 1.7, that'll get us to 7.7. If we add another one, that'll get us to 9.4. And if we add one more, that's going to give us 11.1. And just to check to make sure we did it correctly, 11.1 plus 1.7 does take us to 12.8, which is what we wanted.